You may ask, what is a wave? Well, the ocean has waves, right? Well, yes, but we're missing a big part here, and it is called electromagnetic waves. What is this, you may ask? Well, it ranges all the way from gamma rays to long waves. And this includes our radio waves, our visible light, X-rays, ultraviolet, and so on. A simple way to explain waves is basically transferring energy from point A to point B. Now, let's look at our ocean wave example. As you know, this is just a big hump of energy flowing through the ocean. What's very interesting is that if we look at every separate water molecule, it is actually going straight up and straight down. You may ask, well, how is this wave moving across if the molecule is going up and down? That makes no sense. Well, actually it does. Let's look at every single individual particle, and we'll plot them out. And as you can see, as these molecules move up and down, and back down, this appears to be a big hump that's moving across the ocean, when really every individual part is moving up and down. This is called a transverse wave. Another common wave is the compression wave. A good example of this one is actually very common. It's sound. What happens in the air when somebody speaks? Well, actually, if you look at all of the air molecules, and I'm going to do a poor representation of somebody's head, as they talk, basically what's happening is in the air, it's almost pushing these molecules and condensing them. So we get some kind of wave going across. So imagine that these lines are compressed or condensed molecules of air. And as it comes to somebody's ear, this wave of energy in the air actually hits the eardrum, and our eardrum interprets the wave. And these are just compression waves in the air. So another good example is, let's say, like if we have all of our, or another way to see it is, we have very less dense air molecules, and then let's say we have really, really dense air molecules here, and then we have another little area of less dense, and then a very dense area of air molecules, and then it just keeps repeating. And you can almost plot this out. So if we made some kind of graph, you know, it's less dense, and then it gets more dense, and less dense, and more dense, and that almost actually looks like a wave that we recognize.